Hey everyone, this is Edwin Hernandez, and this is my video for the Lab 5, and I chose the Slinky Drop. So in this lab, I dropped a long Slinky to test out the theory that the bottom of the Slinky stays until the top comes down and pretty much touches the bottom of the Slinky, and they both start to come down in unison. My Slinky that I have is 10 centimeters tall, 8 centimeters in diameter, and weighs about 0.4 kilograms. And it's a fairly new Slinky. I bought it just before I filmed it, so that's pretty much what I have right now. So the model that I used was pretty much a video recorded drop of me holding it at around my height and dropping it, and like having the bottom of the Slinky about halfway through the height of my of halfway through my height, so I can have a general measurements of what it was. So here's the video in tracker files. So here you see the Slinky, and as it's dropping, here's the bottom of it, and it's going down. This is the graph of the top part of this part right here when it's going down. And as you can see, they both go around in unison at around 0.4 seconds. And this is mass B, which you can see it's uh, flat until at that time at around 0.35 and 0.40, uh, 0.4 seconds. And it wasn't that much of the frames because it's a short video. It's a long video, but the time frame that I filmed it at, it was a pretty short time frame when I let go of it and it dropped. So some of the theories that I used in this lab were were in action during this lab were Newton's second law, which we know that force equals the mass times the acceleration, and we have used it countless times to do the free falls and constant acceleration and the free fall of objects. So this experiment kind of simulates it a point as mass A, where I have the top part of the Slinky right here in my hand. That actually simulates the free fall object that we did in Lab 2 of our 5 labs. Lab 2, that's pretty much what it does. And this is a generalized theory, but this actually equates to using force. For this one, I didn't do a, uh, a glow script to model my Slinky drop, but this will be probably the same idea of trying to make two different scripts, one with air resistance and no drag resistance, and the other without it. So we can check for mass A the velocity, the positions, and for mass B, know like similar what we need to do for that, but for mass B, it'll be pretty much the same for what we did for mass A because pretty much they hit at the same time and they went down at the same velocity and all that. So, excuse me, that could be one of them. And also another theory that was also applied uh, is the momentum principle, in which we know that if we drop something, it has initial momentum, it has its initial energy, its potential energy, and when we drop it, it holds the potential energy of the bottom does not it doesn't get transferred down until the rest of the slinky gets close enough that the transfer of energy comes down and hits the bottom part of the velocity of the slinky. So the bottom of the slinky registers a little bit later after the fall, so that pretty much equates the energy principle, not the momentum. So thank you for listening to my lab report, and I hope to grade all yours. Thanks.